arithmetic sequence. An arithmetic sequence, or what we usually know as linear patterns. We've dealt with this since grade 8, so this is not new. Except that in grade 12, a arithmetic sequence is more vague, it's more application. It tests you on your use of algebra. But this is just a brief introduction. So an arithmetic sequence is a sequence with a constant first difference. Right, so if you recall from the quadratic sequence video, the first difference of a quadratic pattern is linear. And the second difference of a quadratic pattern is constant. Now, an arithmetic sequence has a constant first difference. And we usually write the form of a arithmetic sequence as Tn is equal to Bn plus C, where B is the constant difference and C is the constant term. Tn and n stay as they are, input and output values. Output and input values respectively. Now, in metric, there is a different form to this pattern. So there are two ways to do it. The first way is one of the ways. But now there's also a second way where we now have Tn is equal to A plus n minus 1 d, where A is the first term and d is the constant and d is the constant difference. Now, this is math. You can use either base formula to get the pattern as long as it's the same. But when you quote a final answer for a pattern, always quote that final answer as Tn in the form of Tn is equal to Bn plus C. Right? So let's now just do a quick example. Let's say you had the number pattern. You had the pattern 1, 4, and 7, right? You had this pattern 1, 4, and 7. Okay, let me just split the information. You had the pattern 1, 4, and 7. And the question is basically going to ask you, determine the nth term. The question is asking you to get the nth term, right? Now, there are two ways to get the nth term, and I'll show you both ways. But first, we need to remember that the difference, right, is always equal to Tn plus 1 minus Tn. Right, that means this difference is always equal to Tn plus 1 minus Tn. So that means the difference of T2 minus T1 is the same as the difference of T3 minus T2. So we have this pattern and they're saying get the nth term. There are two ways to do it. The first way to do it basically involves using Tn is equal to Bn plus C immediately. Now, you do your little tail before you even start the question. Why? This is so that you have all the information you need immediately. So 4 minus 1 is 3. 7 minus 4 is 3. So the constant difference here is 3. Now in this pattern, we know that B is equal to the constant difference. Therefore, B is equal to 3. Now, when we continue, C is a constant term. We have the first term of this pattern. So therefore, C is equal to T1 minus B. T1 is 1 minus the constant difference B is 3, which means that C is negative 2. So now when you write your final answer, you get Tn is equal to 3n minus 2. And that's the first way of doing it. Tn is equal to 3n minus 2. Now, the second way of determining the nth term of an arithmetic sequence is using the formula Tn is equal to a plus n minus 1 d. Now, remember what I said. I said that a is equal to the first term. So a is equal to 1. And I said that d is equal to the constant difference. So d is equal to 3. Now that we have this information, substitute it into the formula. So you now say Tn is equal to 1 plus n minus 1 times 3. But remember what I said, when you quote your final answer, it must always be written in the form Tn is equal to Bn plus C. So you continue it. 3 times, distribute that n minus 1 to that 3. So now you are going to have 1 plus 3n minus 3. Therefore, when you look at it all, Tn is going to be equal to 3n minus 2. And that's your final quoted answer. Now, there are some pros and cons to each formula. A pro of the second formula is that if you are given values and they tell you to determine a certain term of a number pattern, for example, they tell you for this number pattern to determine a value that is equal to 154, you do not have to do that first. So T what is equal to 154? That's the question here. You don't have to go here immediately. You don't have to do this and get that this is equal to 3n plus 3n minus 2. You can simply use this formula, Tn is equal to a plus n minus 1 d as is immediately to get the answer. So you'll just now substitute 154 is equal to 1 plus n minus 1 times 3. You substitute it, you continue it, where now you get 153 is equal to 3 times n minus 1. You can now divide both sides by 3. Therefore, n is equal to 52. right? Now, and this would have equated to 51, but then I already just added the 1 over there to give you n is equal to 52. That's a pro of that second formula. But a pro of the first way of doing it is in the event that you don't get T1 immediately. Then you can write it as is like this. Tn is equal to Bn plus C. Substitute the values they did give you of a certain pattern. So for example, let's say they gave you this information. They told you that T4 is equal to 6 and T11 is equal to 19, and this pattern has a difference of say 3. Now you can obviously apply the formula. You can obviously apply this. You can say Tn is equal to Bn plus C. Oh, okay, let's just remove that part. T11 is equal to 19. Sorry. So they tell you that T4 is equal to 6, and they give you that the difference is equal to 3. You say Tn is equal to Bn plus C. We know that B is equal to 3. Therefore, you get that Tn is equal to 3n plus C. Now, you know that when n is equal to 4, you get 6. So therefore, 6 is equal to 3 times 4 plus C. Right? So now you're substituting values and you're going to just solve for C. So to solve for C, you simply say 6 minus 12. C is equal to negative 6. Therefore, your pattern is Tn is equal to 3n minus 6. And that's a pro of the first way of doing it. But regardless of the way you choose, as long as you can get to the final answer, you are correct.